So the quadratic formula is something that we can use as a formula to solve for any general quadratic equation of the form ax squared plus bx plus c. Now to generate this formula, what we can do is we can solve this general equation with the variables a, b, c. And if we solve this general equation for x, what we'll end up with is a formula that allows us to solve for x in terms of the variables or the coefficients a, b, and c. So you don't need to generate this yourself, but essentially it's completing the square. And see if you can follow along with the steps. Make sure you understand each individual step. Okay? You don't necessarily have to be able to do this from start to finish because of all the variables make it a little bit more challenging. However, make sure you understand each step because each step is an algebraic step. And that's something that you need to make sure that you know how to do. So the first thing that we're going to do is we're going to get rid of the constant here, plus c, and we're going to subtract c from both sides. And that allows us to just deal with these x variables. Now we're going to complete the square with the x squared and bx. However, to complete the square, it's much easier to factor out the a. So what we're going to do is when we factor out the a, essentially we take the a out in the brackets, and so we're dividing by a. So we're going to take that a out by undoing the times a by dividing by a here. And so we end up with this expression in the brackets. And this bracket part here, I'll just highlight this. This portion here is a part that we're going to complete the square with. So to complete the square, what we're going to do is take half of the middle, okay, and we're going to square it. Well, actually, sorry, in this case here, what we've done first is we just want to isolate the square part. So we're going to get rid of the times a by divide a. Then we're going to take half of the middle and square it to complete the square. So we take half the middle, it's going to be b over 2a. We square it, we end up with b squared over 4a squared. And to balance out the equation, we need to make sure that we do that on both sides. Okay? Otherwise, we end up with an unbalanced equation. So this is our completed square here. This is a constant term that we're left with. Since this is a completed square, we're going to write it in a squared form. So we're going to end up with x plus b over 2a, because remember that b over 2a represents half of the middle term, squared. And here we're just going to combine these terms by finding a common denominator. So the common denominator is going to be 4a squared. So this fraction is missing a 4a, so we're going to times the bottom by 4a, and we're going to times the top by 4a to get 4ac on top, and there's our common denominator. So then we want to square root both sides to isolate the x. Okay, so we're going to get rid of the square by square rooting. Now in this case we just switch this around a little bit, so instead of doing negative 4ac plus b squared, we're going to do b squared minus 4ac. And then we get the square root. And remember that anytime we undo a square, we always have to consider the plus and minus version of that solution. So the last step then is we're going to get rid of this plus b over 2a. We're going to do minus b over 2a. Looks like you can put the minus over here. So we're going to subtract b over 2a from both sides. And we're going to end up with this equation. So putting over the common denominator, so here the 4a squared, we square root. We end up with a common denominator here. And our formula ends up being negative b plus minus square root of b squared minus 4ac over 2a. And I want you to recognize something here, that when we solve for the quadratic, solve for the roots of a quadratic, the roots are symmetrical about the vertex. So I want you to notice that here there is Vieta's formula. That represents the center of the parabola. Remember, the middle of the parabola is the most important thing in a quadratic. Okay? That's the most distinctive feature of a quadratic, is its symmetry. So there is its middle, and the two solutions for that cross the x-axis are going to be plus minus this amount from the middle. So we're going to go plus to the right, that amount, and we're going to go minus that same amount to the left. And that gives us our symmetrical solutions about the middle part of our quadratics. And there is a middle of our quadratic, our Quadratic formula, the x-coordinate of the vertex. So basically, this quadratic formula can be used to solve any general equation that's in the form ax squared plus bx plus c. So all we have to do then is to solve this, any quadratic equation equal to 0, we just have to identify the a. So in this case, a is going to be 1. We identify the b value. B is 5. C is 6. Okay, and then we plug it in. So the solution for a quadratic is x equals negative b plus minus square root of b squared is going to be 5 squared minus 4. A is equal to 1. C is equal to 6. Okay, so there's there's the top numerator, and the denominator is going to be 2a. So in this case, 2 times a is 1. When we simplify this, we end up with negative 5 plus minus the square root of 25 minus 24 is 1 divided by 2. So that simplifies to negative 5 plus 1 is negative 4 divided by 2 is negative 2. Or if I go negative 5 minus 1 is negative 6 divided by 2 is negative 3. So those are two solutions. Now we can confirm this by actually factoring this, because this happens to be factorable. Okay, so we can actually factor this into x plus 3, x plus 2, and again we can get our solutions from the factored form is going to be negative 3 and negative 2. So the quadratic formula does work, and it should work because we've solved for the general equation with the coefficients a, b, and c, so we can use the a, b, and c values and plug them into our quadratic formula to find the solutions.